section 5.6, we have angle, side angle, and we have angle, side. So you can, if you want to go write down the theorems, you can. I'm not going to waste your time on that right now, but for angle, side angle, we'd have to have like angle, side angle. Like they need to go in order without like skipping. Like if you worked your way around the triangle, you'd go angle, side, angle, side, angle, side, angle. Like if you go to each thing. So it has to go in order. Angle, then the side, then the angle. And the theorem like says that if two angles and the included side, so the two angles and then the side that kind of connects those two angles is another way to think about it. Okay, so the angle side is the only one that really doesn't go in order. So it's going to be any two angles, but then one of the other sides, not the included one. So basically, if you have two angles and a side congruent, you're going to have a congruent triangle. It might be angle, side. It might be angle, side, angle, just depending on which one of the sides is congruent. Okay, so there's really not anything super different in this section compared to the other ones. It's just different reasons. So I'm going to do a problem that doesn't do this, but we've seen this like picture here, trying to prove the two triangles congruent. I can create a proof that uses any of the 5 different reasons that we've gone over so far, or there's only 5, but the 5 reasons that you can prove a triangle congruent, just depending on what information is given to you at the beginning. So I could do a side angle side, a side side side, a hypotenuse leg, an angle side angle, or an angle angle side with this picture. So it's just dependent on what information is given to you. Okay, so the questions will be like they were in the previous days. Is there enough information to prove the triangles are congruent? There'll be some that will ask, it'll give you a side and it will give you an angle, and then it will just say what is the other information that you need to be congruent. So that's a little bit of a different. So if we had I don't know why it's gray. That's kind of weird. So if it said that, let's say AB and DE were congruent and angle A and D were congruent. So if you had to use angle side angle, okay, then what is left that needs to be congruent? Then you would just write angle B has to be congruent to angle E. So it would make that one and that one congruent. I should put 2 right there. Okay, so then we have angle side angle. If it said for angle side, then you would have to say that angle C is congruent to angle F. And then it would be like this, and then that's angle, angle, side. Okay, so you'll have a few problems that'll just, fill in the blank kind of thing. But it will tell you, so pay attention to that part, which reason you have to use. One of them will be angle, side, angle, and the other is angle, angle, side. Okay, so let's look at a proof that involves something that we haven't necessarily talked a ton about. I don't want to do that. It's kind of like, call it a bow tie problem. So if it said given AD is parallel to EC, so I labeled that already, and then BD is congruent to BC, so BD is congruent to BC. Okay, and then prove those triangles are congruent. I forgot to put the triangle in there. ABD is congruent to triangle EBC. Okay, so step one, write the given. Then make conclusions about the given. So, let me back up. The other thing, like I have a side right here that's congruent. Okay, so parallel. Remember, if something's congruent, there's no conclusion to make. Parallel. When you see parallel, alternate interior angles need to come into your head. Like that's almost always what it's going to be when the lines are parallel. So I could say that angle A is congruent to angle E, and that's alternate interior angles congruent. So you could, this problem has multiple solutions. You could, and I'm going to show you like both, but you could also say that angle D is congruent to angle C for alternate interior. Angles are congruent again, just it's different transversal. So you could do that, in which case, and I'm going to leave a space, here's an angle and here's an angle, and when you look at it you have angle, angle, side. So you could say that triangle ABD is congruent to triangle EBC, and you would say angle, angle, side. So on this second one, if you didn't do two different angle or alternate interior angles, you could look at it and say that angle ABD, this one right here, is congruent to angle CBE by vertical angles are congruent. And so it's just a different angle, angle, side. It's still angle, angle, side. So on some of the problems, just depending on what you see, it may depend on how you write it up. When I see two triangles, kind of like again, I call it a bow tie, but where they're connected together with the point, I automatically go, hey, those angles are congruent vertical angles. Like I already know I'm going to do that. But it is possible for the other angles to be congruent, with the alternate interior. Okay, so, the proofs are, there's one of the proofs involves parallel. So again, well, oddly enough, corresponding angles will actually pop up in that one. But there's perpendicular. So remember, when you say perpendicular, you're going to say that they are right angles first. And then are you going to say that right angles are congruent? Or are you going to say that you have right triangles? And that depends on if you're going to use hypotenuse leg or not. So it just also depends on what other information you already have congruent. So watch out for that. On one of them, it gives you stuff that's all that stuff is congruent, but you're going to be able to use isosceles triangles, like the base angle theorem that we talked about a couple sections ago. So if two angles at the bottom of the triangle, if these two angles are congruent, then the base angle theorem says that AC is congruent to AB. The sides opposite them are congruent. Okay, so that'll come up, excuse me, on one of the problems. And you'll still have on one of them you'll have a reflexive property that we use. So it's just different versions of proofs giving you different pictures, but it's still the same general idea. Write the given, make conclusions from the given, and then use the picture to give you any other information that you might need. And that's usually just reflexive, vertical angles, or it could be isosceles triangle, like the base angle theorem. So that will come up on one of the problems today. Okay? All right, keep working at it. Keep asking questions. You'll get better at it. All right? Have a great day, guys. We'll see you tomorrow.